Just as a summary again, so this can be an hour-long session. Typically speaking, I'm going to give you about 45 to 50 minutes or so for the problem solving, and I'm going to ask you to control the time on that one, and then
Okay.
we'll have 10 to 15 minutes at the end for discussing the problem, going over any questions or concerns you might have. Okay.
Okay.
Okay. So for this problem, I would like you to write me a function or a method in Java called number of provinces. Okay.
Hmm.
And by the way, feel free to take notes inside the coder pad, just wherever you prefer.
Okay.
Yeah, so
So let me start
like you for you to write me a
here.
function called number of provinces, and okay, yeah, you can go set up the file as you need.
Mhm.
Yeah, so the input to this function will be a essentially an adjacency matrix. Okay, this is it's an adjacency matrix, where of course the value is true. It's a boolean. It's a boolean adjacency matrix. It's a value of true if and only if the nodes correspond to indexes of the matrix are connected.
Mhm.
Okay. And your goal is to return. And so these by the way these nodes are cities in this context, and cities that are connected are part of the same province. Okay, so I would like you to write me a function that takes in this adjacency matrix and returns a number of provinces in the graph.
Okay, so it takes in.
If you're talking, I can't hear you.
Oh, hello.
Okay, you're good now.
Yeah, I'm sorry. I'm just trying to like visualize this because
Okay.
yeah, I probably should have mentioned as well that adjacency matrix are probably my weakest topic. Um, we have adjacency matrix, and that consists of cities, right? Or is it provinces?
So the nodes in the graph are cities.
So there's cities. Uh, mm, so look at the graph. Most cities. Yes. And we know that cities are connected if you're gonna.
So where are we at right
Okay,
now?
so and what I'm thinking is, So we have a matrix. Um, so we could pretty much say that if so the sorry, so like if the graph is full of cities and we want to determine the number of provinces, correct?
Yes.
So if they're connected, so for example, if we're iterating through the graph, if row if our row and can we assume that if our row, for example, row I or not row I, sorry, graph I and J is equal to one for say that's a connected city.
Yeah. Cities are connected if they have an edge between them.
Hmm. we- So the approach that I'm thinking about taking is having two nested for loops. It's gonna be like int or and like for example column. And we know that if cities are C equals to one that they're connected. Mm,
Yeah. So we're looking at cities connectivity, right?
yeah.
There's two things that I need to care about here. The first thing is that you need a given a city, it must be in a province,
Hmm.
right? If it even if it's in a city that's not connected to any other cities, it's still its own province. Okay.
Hmm.
Otherwise, if it is connected to other cities, then all of the cities you can reach from that original city are all in the same province.
Hmm.
So in other words, we want to traverse all the cities, okay? No matter
Hmm.
how many times we have to quote unquote reset because you can't reach a city from another city. Right? So you can't reach a province from another province, right?
Yeah.
So, once you search through all of the cities available from the current city, that's one province.
Yeah.
And there's no other cities that can be in that province because you already traversed them all.
Okay. Mm.
specifically the property we're looking for here is traversability.
Mhm.
How do we traverse?
So to reverse, we'll just like for like example, if it's a grid to go through all the cities, we'll just do the nested for loops and check each row and column of the
Okay.
matrix.
Yeah, and if and what would you do with it? Right. The
Uh,
issue is not traversing the grid. It's
mhm.
the grid is not the graph. The grid represents the edges of a graph.
Yeah, and so
What sort of traversals are you familiar with in terms of graphs?
graph like breadth first search, depth first search.
Okay. Yeah, those would be useful here. So we
Yeah,
can pick one of those two
yeah.
and think
I'm thinking
about the
about.
problem from the perspective of a traversal.
I want to use breadth first search. I'm just trying to kind of visualize how I would go about this. Um,
It's good to start with pseudocode. Okay. So you
yeah,
BFS. Okay. You have some inputs. What do you want the outcome of BFS to be?
the province count, I would say. Like I wanna we want to traverse and pretty much find the connected cities.
Okay.
And
So
as
you
we
can okay. Find all connected cities. And then what?
and then once we find the connected cities, you can assume that's a province.
Yes. Okay. So after BFS finishes, all connected cities are a province. Okay.
Mhm.
And then
And then we'll we could have like for example variable like int provinces, and we'll just add the province or increment the province count. Uh, but we want to make sure we don't reiterate over cities we've already checked.
okay.
We would we'd probably we'd have to track cities that we've already visited. Mm,
Yeah. No. Keep thinking. Okay. So
and
so so okay. So let's get rid of that for now. We can leave it. We have a province. This is our return value. Yeah.
mhm, yeah,
After BFS finishes, what do we do?
we so after BFS finishes, we increment. Well, let's see BFS, and then we can say, for example, provinces. We find province. Uh, we would want to, since we know that these cities are connected and these make a province, and that no other connected city would be this province, we want to probably track the cities we've covered and then go keep iterating and find the next city that we haven't um burst through yet.
Okay.
So we could have a data structure to store, let's say store visited, and say if this is equal to one and we haven't visited, we can call the breadth first search again, find all the connected cities once again, and then return the province. Now,
Okay, and so and so ideally, what would the inputs? So obviously, I just abstracted this away. So what would the inputs to BFS be?
so the inputs to BFS would be we'd want to pass our cities matrix. Let's say cities, or sorry, this would be ints. We'll say cities. We'd pass in our row and column, and we can also pass in our visited collection. And final cities. So we could use a uh,
So what else is a concern right now? Can we get started, or do you think there's still some edge cases you haven't considered yet?
um there is one case. So I'm trying to so I think for the most part, uh this part is good. It's the actual BFS itself. I'm trying to actually determine uh how to detect neighbors or sorry, cities are connected. Like
Well, I mean, they're connected because you have a adjacency matrix, right? So if
yeah.
the value is one, it's connected.
Mhm. But in the case where it's so if we know a city is connected to a city, that's a starting of a province, you could say, right? And then I'm trying to figure out like how to keep iterating through these cities to see how many are connected to each other. So that's kind of what I'm uh,
Well, a
figure out at
city
the moment.
without a connection to another city is still a province.
Mhm.
So you don't need to connect to another city for it to be a province.
Mhm. Okay, so yeah, we can start. Okay, so I'll start by writing the first function where we take in the our cities grid and we start iterating through it. So start by running a over function returns int, and we can call it a number of provinces. Oh, oh yeah, so okay. So I'll take in matrix of cities. Now we need to have some type of data structure to store visited. So I think we could probably stick with. We could probably use a set of. And the reason I want to use this set is because we know that sets can't contain duplicates. So we have our set. We want to create a variable to store our result provinces. Initialize as integer 0. And then I'm going to actually create some. So create the row and column index pointers, rows, or sorry, length. I'll start by writing. That's what the ints are equals 0. Densities are. Okay, so the second loop. E plus plus. And if equal to 1 and not visited. Mm, was actually this would be it's a string and then just say if we haven't visited the current are separated by comma t. That's confusing. Okay, so we have the nested for loops. We have to check to see if the current cities have an edge, and if we visited them, and if they do and it's not visited, we can call our BFS function that will take in the cities matrix, the row, column, and visited. And then after it runs, we can determine it's a province and increment province. Now we have to write the code for the. Actually, that's not gonna have a. Now we'll actually write the BFS. And okay, so we'll keep track of cities is a queue. Just say it's queue. Okay, so we'll start by passing the queue the first city. So we'll offer it a row and column, and we can say that.
Okay, hold on. So your queue is a queue of integers, and you're offering it a list of
Oh
integers.
yeah, sorry. This is a
Okay, can you explain why you have a list of integer here?
so this is the current position that we're at
What is a position mean?
in the cities.
Yes. What does a value in the cities mean?
A valley in cities is like a city, and then
So, can you
or
clarify?
sorry, it's edges.
Yes, it's an edge.
Yeah. Um.
Okay, so you're passing in an edge.
Yeah.
Okay.
So these. Yeah. So this is a queue of edges. We're passing in edges, and yeah, and then we're gonna pass and visited, saying that this edge has already been seen. Um. So the approach that I'm thinking about taking is like just a queue, and while the queue is not empty, we pull from the queue our element, and then so we'll pull from the element, or we'll pull from the queue our element and check if one, it doesn't exist in the visited set, And then two, if it also has, if it's also connected to another city. So as we're reversing, we can keep adding the ones that we checked and visited, and then adding into our queue uh, edges as they exist. And then when we get to the point where our queue is empty, meaning that there's no more edges, that will just determine the end of the province. That that kind of makes sense, or
That kind of makes sense. And you
yeah.
should go with that understanding with your current time, and we can
Hmm.
talk about the rest later.
Okay. So we can say yeah. So I should keep this more simple. Yeah, since we use strings here already, we'll just say well, queue is not empty. Okay, and so, so entity as equals queue dot full and row. Yes. This. and so okay, so
Yep.
the okay, so we can see pretty much here that if not visited, that contains. As yeah, I was kind of thinking about it, and I definitely see a better way to do this. Yeah, so to clarify for this cities matrix, um, each so for like for example, each array in the array cities
Okay.
can the cities in that array only the cities in that array be connected.
So can you say again?
So for example, this might be easier if I draw this out. So we have, for example, three, like let's say one, two, three, four, five, six. Or sorry, actually it should be one, like one, zero, zero, one, one. So
Okay.
in this case, are we allowed to, like for example, like these two are both, for example, one. Are we allowed, or are cities allowed to be connected to other arrays, like between arrays?
Of course.
Okay.
I mean, this is not a validation matrix for the first place.
Yeah, no, yeah, just
Yeah. Okay. Just so you know. But yeah, of course. So this corresponds to the fact that index zero and index zero can to each other. That make dude, this is like the diagonal doesn't make any sense. So the diagonal is always one. That makes sense, right?
mhm.
This just means that uh, node. So this would be node index one connects with
Yeah,
node index zero.
yeah.
That's all that means.
Okay.
And this being true also necessarily means that this is true, but it doesn't matter.
Mhm. Okay. Mm, So city is roll it roll uh, yeah, I definitely do think I kind of dug myself into a little bit of a hole here.
Yeah. Let's do
Yeah.
this then. let's from here on write pseudocode
Hmm.
and tell me what you want each line to perform, and then we can go from there.
Yeah, so pretty much, I pretty much want to see. So we have the first edge here. We pass in the edge, and we know this edge exists. So pretty much what I'm going to do is I'm going to keep traversing to see how many cities are connected. Uh, so like yeah, we pass in the first one, and I'm going to keep iterating over and seeing okay how many. So like A is connected to B, and then I want to see city B if city B has if there's a C that exists, like is it connected to a different city and so forth. And if it is, then we want to add it into the queue if that exists and we haven't already visited. I want to add it into the queue and mark it as visited and then keep iterating till we eventually reach a point where the queue is empty, meaning that there's no more cities that are connected. And that will in return, or the BFS will then return, and then we'll mark that as a province. And we'll have the collection of visited cities already, and then we'll keep iterating through and find the next uh, edge that hasn't been visited yet, and then once again just keep iterating through the BFS. Does that make sense?
Okay.
Yeah.
Yeah. Let's quickly discuss the time and space complexity
Okay.
for the solution. Yeah.
So the time and space collects complexity. We know that we won't always call BFS or increment provinces because that'll only run if this is true. For example, if there is an edge that exists. So the most run, I guess, line of code in this case would be this one right here to compare the check, which will run. We'll just say rows times columns amount of times. So it could be, for example, if they're different sizes, m times n.
Okay.
So it would have, and then this, yeah. So this, I know the BF, yeah, that doesn't really matter. So it'll just run up m times n, or big O of m times n.
And what is m and what is n?
M will be, for example, rows times columns.
Okay.
Yeah,
And why are we not? And why are we discount? Why are you not counting the complexity for BFS in this case?
yeah. So we're not counting it in this case because we won't always actually run uh the BFS. So yeah, so the BFS won't always run. It'll only run if this condition is true.
And
But
how
we
many
know for
times will it
sure.
be? And how many times will it be true?
Uh, how many times this condition will be true?
Yeah.
It'll be true. I guess it'll be true according to the amount of edges between cities exist.
Okay. And what's the worst case?
Yeah. So the worst case, for the whole function, correct?
Oh, for big O complexity, what's the worst case of the sample input?
Oh, the sample, m times. I would say m times n.
Okay, so it can run m
Yeah.
times n times. Okay.
Yeah.
And so and so what's the complexity for BFS if it runs that many times? If your overall time
So
complexity is m times n, then you must say that BFS is O1. Is that the case here? Can you justify that?
yeah, so this runs m times n. Time complexity of BFS would be, I would so Yeah, so it would, I think BF, it would depend, it would run on the amount of edges exist, and we know that the edges, the amount of edges is equal to roughly, okay, so I think is edges equal or less than equal to vertices squared. Um, yeah, so the time complexity of the BFS would probably be, it wouldn't be constant. Then,
Okay.
um,
Do you have any intuition for what it might be if you don't think it's constant? Okay, let's go to the space
yeah,
complexity.
I think it's, I would just say, I would just say according to the vertices, so I guess O of n, I want to say,
Okay, let's go to the space
or,
complexity.
or V squared, yeah. Okay, space complexity. Um, yeah, so for the space complexity of this, I want to say B of n, because n being the amount of elements in cities, since we want
Okay.
to visit all cities. So as we visit them, they'll be stored here. So we know for sure that our set, we're gonna have to visit every city, and we know that they're all gonna eventually be visited and be stored in
What are we
our
storing
set.
and visited?
What are we storing and visited?
Yeah, yeah. What's going to visited?
The edges that we visited.
Okay, and how many edges are there?
The edges equal. This should be in worst case. This should be worst case n squared.
Okay.
Yeah.
Okay. Anything else you want to add about the timer space complexity?
Mm, mm, no, I think that would be Ash.
You have a queue over here. Does this matter?
Yeah, yeah. Um, so in the let's see. So yeah, I would still say worst case of yeah, I would still stick with the same
Okay.
because yeah, worst case.
Yeah.
Yeah.
Okay. Then let's call it
Okay.
here.
Okay.
We'll wrap up this interview as is, and we'll go to the kind of discussion and feedback here. Okay. So, I like to open this up and ask you, how do you feel? What do you think? And we don't have that much time, so maybe let's be a bit quick about this. But what do you think went well?
Mhm.
What do you think, was a weak point here?
I think definitely a weak point is kind of, as you can see, dug myself in a hole. I don't think, I mean, like I kind of mentioned in the beginning, I don't have a lot of experience with adjacency lists, so I think I kind of approached this in, I think I kind of approached this in a way where I was thinking about it as like, for example, a question like number of islands,
Okay.
when I shouldn't have thought of it in that way. Um, so yeah, definitely going at it in that sense dug me into kind of a bit of a hole when I got to the BFS portion.
Okay.
Um,
Um, I can, yeah. So I mean, a couple of things here. I mean, so I'm glad you brought that up. This question is actually exactly the same as number of islands.
Mm,
It's just that the representation of the graph is different. It's an adjacency list or
yeah,
matrix, rather. Um, right. So I think, I mean, if you know, if you've in the past you've solved number of islands, then obviously this probably would have been able to solve if you had understood the adjacency matrix structure. So of course
yeah,
the homework there is to go study that. Make sure you get familiar with that.
hmm
But I'm not gonna talk about that too much. Um,
yeah,
we can go over some general kind of notes I've taken here that I think would be helpful. The
hmm
main one here I think is the strategy. Okay,
yeah,
and what I mean by strategy is two things. The first thing is if you're going to companies such as Amazon or all these
hmm
banks for interviews, the expectation is that you will be able to lead the interview when it is your time to do so.
okay,
And there's many ways to kind of consider what that means. The most obvious one, and the one I've alluded to at the beginning of the interview, was that you need to control the time. Okay,
hmm
you need to control the time. What that means is that you need to determine at what point should you move on to the next step, such as when should you move on to design, when you should move on to coding, when you should move on to checking for bugs, etc. Right. So we didn't get that far today. That's
yeah,
okay, but that is one thing that you need to control.
okay,
A second part, what that control means is you need to be aware of when it is better to explicitly ask for help and when it is better to try to grind it out. And
hmm
why that distinction matters is part of the skill is, sometimes if you don't know something, you can't know it, and that's just the way it is. You just take a penalty on that. But if
hmm
you dwell on it and you don't recognize that you can't know it, then it
hmm
also looks bad on a second spectrum there, right?
yeah,
So if you recognize you don't know something, then it's good to just immediately ask for help, immediately try to get yourself out of that hole, and save yourself the time and embarrassment later because the points have already been deducted. The points have already been deducted for not knowing adjacency matrix, right? Like
hmm
those points are gone, but
hmm
you can still save the points elsewhere, right?
okay,
So that's a strategy kind of thing there.
yeah,
A couple things to also just call out here, just off the top. Quite a few hints given at the beginning. Okay.
hmm
And that's because I recognized very early on that you don't know what this problem means in terms of the adjacency matrix, right?
hmm
Uh, and more generally speaking, interviewers who might not be as kind and helpful, you needed to have that initiative a lot more. So this goes to my previous point. You need to know when to ask for help. You need to know when to do X, Y, and Z. And what might
hmm
help you do that is by practicing thinking out loud. So while
hmm
that's not explicitly a required skill for interviewing, that drastically helps things that are good skills, like
yeah,
communication, like knowing when you're stuck, like helping the interviewer help you, etc. Right. So if you're not
hmm
communicating that either through writing it on the board as you're going through the problem, or if you're not doing it via, for example, and these are examples, right? We're not doing it via talking out loud or doing it via scaffolding code, writing comments, etc. The interviewer doesn't
hmm
know what you're thinking. They don't know how to help, right? In
yeah,
this case, obviously, I know the weaknesses, so I can help. But some interviewers, they might choose not to because they might want to test your skill of knowing when you're stuck.
hmm
So in that case, you would have failed in that front. Okay.
hmm
So, but I think one thing that was going to call out here is that once I did provide some thoughts, some guidance, you were able to take that a bit further. I think that was good. Now, obviously, it's not just about taking it further; you have to take it across the finish line. So that's kind of where there might have been a gap there. But I think
yeah,
again, this is just due to a bit of lack of knowledge for the adjacency matrix. Now,
hmm
another thing that I will say is a general skill and strategy for these things is you should diagram more. You should diagram more and more often. So, for example, in CoderPad, there's the drawing pad, obviously. In other, different toolings, there are other things you can use, right? What I will say, again, is I think you would have avoided a lot of the confusion with your types. For example, with your linked list type in the BFS,
hmm
and you would recognize a deficiency in your string type when they're widget set if you had diagrammed the adjacency matrix out. So
hmm
what it might look like in this case is for you to essentially draw out a graph that you want to solve and then draw the adjacency matrix that represents the graph. Okay.
okay,
That's something which I would recommend you do more often because it will, especially if you don't know the problem and the solution right off the top of your head, that will almost certainly save you time.
okay,
Okay.
hmm
So otherwise, I'll say let's take a look. There's a couple other things I'll say just as notes. BFS, DFS. Obviously, I told you can pick either one. Um, the one you pick, you should be really, really familiar with. So in this case, one thing I will also suggest again is you're writing common template code, like for example, setting up a BFS. You
Hmm.
shouldn't you should don't start off thinking about how BFS relates to the problem necessarily. You should just
Hmm.
immediately bang out a BFS template, right? And it should
Okay.
take you, I wrote here, it should take you 1 minute max to write out a generic BFS, and then go back, put in the types for the queue, choose to use a linked list or array deck, whatever it is, figure out
Hmm.
what you need to pull, figure out the variables, for example, in this case, what the variable would be if you were to pull it out, right?
Okay.
So write the generic BFS immediately first, and then change the variables out, because that way you can only get confused on one front, right? That
Okay.
way you don't get confused on both fronts. Like in your case, you couldn't figure this out. That's because you got confused in how this problem relates to BFS. So the outcome is I can't tell if you don't know BFS or if you just don't know how the problem relates to BFS. Okay,
Hmm.
so again, save you some points there. Um, let's take a look. Okay, and then just to wrap this up, I'll talk about the time and space complexity. So
Hmm.
I'm not going to comment too much about this because you didn't finish the problem, but I still wanted to kind of get your gauge on understanding of the time and space here. Why do I
Hmm.
say that? And I say that because there's a bit of a nuanced actual, let's say, there's a more nuanced analysis of this problem that's available that most other problems don't have. Okay, so the first thing I'll say is that let's go to time. M times n. First thing I'll say is that the adjacency matrix is a square, right?
Yeah.
By definition, it's a square. So there's no need for a row and column variable. It's the same variable, right?
Okay.
Now, you originally did say that, well, you originally did imply that BFS was constant time. Okay. Now, that is actually correct in this case, but you weren't
Hmm.
able to justify why. Okay, so this will go. So this will go, into that pool of problems where, of course, you can come up with the correct answer, but if you can't explain why it's correct, it might as well be incorrect,
Hmm.
right? The intuition for this problem is sort of what you alluded to, which is that you will only visit every node once.
Hmm.
In other words, you can only add a node to the queue, or in this case, an edge for you. You can only add an edge once because if it's been visited, you will not run BFS. So the sample inputs of BFS are only edges, or in your case, nodes, or in your case, edges that you haven't visited,
Hmm.
which is constant, which is the same constant as, well, not the same constant. It's the same size as your loop.
Okay.
So that's a justification for that. So that's how you would, for example, justify that. Now
Hmm.
space again, this is again where there was a bit of confusion. So originally the answer you gave was a linear time, or a linear space, which is actually correct, but is incorrect for two reasons. It's incorrect because that's not what you implemented, and that's not how you justified it. Right. So it would be correct if you were storing the number of, or storing the cities themselves. That would be
Yeah.
correct, and that would be how the algorithm was originally outlined. However, the way you
Hmm.
actually coded it was you're storing the edges, and there are, as you know, n squared edge, up to n squared edges,
Yeah.
right? So again, there's kind of two aspects to consider here. The first one is that even if you give the answer that is optimal, you have to get the answer that is correct for your implementation,
Hmm.
right? And the second thing is, of course, is that you have to be able to justify any of the questions about why you're making assumptions, because you are right in that BFS, the complexity is usually the number of nodes plus the number of edges, but in
Yeah.
this case, um, that it can be different because we can make assumptions about the input, and we can make assumptions about how often we call it.
Yeah.
So those are some missing pieces there. I think, just in general, maybe some familiarity with BFS, some familiarity with, the adjacency matrix setup. But I think
Mhm.
otherwise, just some practice, and you'll be there.
Okay.
Any questions?
Uh, no, I think you answered majority of the questions.
Okay.
Yeah.
Then thank you for your time. I'll
Yeah.
talk to you in the future. Take care.
Okay. Thank you.